Welcome back to Fullerton College's Printing Technologies Print 101 Intro to Print. This is your professor, Ben Hewitt, and today we're going to look at the Chapter 2 of the 5th edition of Z.A. Prust's Graphic Communications, our yellow-bound textbook, which is about health and safety. Let me start by saying that some jokes don't age well. When I first made these slides, I was teaching 101 a few years ago. And at the time, the idea of wearing an isolation suit was kind of a funny joke of, can you believe how extreme you could be for health and safety? Nowadays, this is a little bit too close to home and a lot less funny than it was. So I'm sorry. I hope I don't scar anybody with this picture. I mean, I'll put trigger warnings, guys in isolation suits. Also, Outbreak used to be a great piece of fiction and is now more or less a documentary. So let's talk about the different types of hazards and safety that you need to take care of on a printing job site. Working with any sort of machine is dangerous. Anything that moves can injure, because anything that moves can put energy into something else. Printing is relatively safe compared to a bunch of other occupations out there. We're not steel workers, we're not shipbuilders, but it has its hazards and you need to learn to identify them and to take care of yourself. From my experience on the job, I can also tell you that you need to learn to take care of yourself. While there are some places that take their safety very seriously and really care about their employees, there are other shops which take a bit more of a laissez-faire approach to health and safety, where they'll let you be safe if you want to, and they probably won't order you to do anything specifically unsafe. And there are those that will, because it'll turn a quick profit and make something a little bit faster. What I'm trying to say is, in the end, while employers can be legally accountable for how safe they are, it comes down to you, really, to ensure that you are as safe as you need to be. There's nobody watching all the time. There's no safety monitor who's going to catch you at all times. You need to have your own safe attitude and always be looking for ways to maintain a full hand of fingers and keep all your eyeballs and such like that. Also, things like our lungs are particularly, what's the word? Vulnerable to some of the printing things out there. One of the biggest things to look at is the idea of machine hazards. Here's some diagrams from your book, lovingly reproduced and put onto your screen. You'll notice they have things like spinning rollers, chains and sprockets, turning gears, rotating belts, basically any part of a machine that's moving energy from one physical location to another is dangerous. I mean, the rotating chains and sprockets, if you're not thinking of bicycles, you should be. My grandfather, who was an orthopedic surgeon before he retired, was always adamant that his grandkids always wore shoes, closed-toed shoes when riding bikes, because if you got a toe stuck in your bike chain, it would be an awful, awful thing that he'd have to try and fix. It does terrible things to a human foot to get caught in a chain and sprocket. And that's just something you might be able to relate to without having operated any machinery, because most of us have ridden a bicycle and have seen the chain and understand that it's a pinching hazard and more than just a pinch. So whenever things move, wherever they spin and rotate and touch each other or come close to touching each other, there's a chance of pulling in and hurting humans, because the machines are not built to keep us safe. They're built to do their own jobs. So these are all mechanical hazards. For the most part, all modern printing equipment has special guards put in place that you cannot get yourself stuck into these places. There are gates that come down or windows and doors that close in front of it. Sometimes there's a little metal wire cage that keeps you from putting your hand in there. And oftentimes these doors, cages, windows, protective guard barriers seem to get in the way of what you're trying to do. And in fact, yes, they do. They do get in the way. In the same way that that guardrail on the side of a mountain road is in your way of that beautiful view off the cliff, but at the same time keeps you from falling off that beautiful cliff. There are places you'll want to clean and need to get to that there's a machine guard in front of. In proper operation, many of these guards, some of them are just simple physical barriers. They're just a rail to keep you from getting in there. Some of them have electronic sensors that if you open them, because you can open them to get to cleaning places, that the machine will not operate. Some machines don't have these operational and the safety barriers aren't functional. These are all things you need to make note of and report to your superiors, whether in school and you're reporting to an instructor and other students so everyone's aware of the hazard, or at a workplace that you can let them know that this machine is not safe to operate. I know I sound like some sort of a hall monitor with a safety sash and a hard hat here blowing my little whistle, but honestly, you know what? You only get one body. Fingers don't grow back. Take care of it. So here's a better picture of a machine guard. A pressure sensitive guard, this is right covering what's called a nip point. A nip point is where two rollers come together to roll and pull paper through, or they have pressure where they push against each other and transfer ink or transfer material from one surface to another by pressure. If you get stuck into that point, that pressure will be applied to you. Can tell you a former teacher here has been nipped by a nip point, although he is retired now and happy. I don't know what he's doing this minute now that there's COVID, but he was happily traveling around the world doing exciting hiking adventures with his kids. Way to go, Mr. Howie. Anyways, he actually has a finger with a flat fingernail. You know, if you look at your fingernails, they all have that kind of crescent domed shape. That's what gives them their strength and helps you keep your fingers stiff for things like typing and picking small things up and biting when you're nervous or whatever, or the movie gets intense. Anyways, one of his fingers got stuck in a nip point on a press and now has a perfectly flat, level fingernail. Things to watch out for. Also, these nip points don't just grab hands. We'll get to this in a little while probably, but they also grab clothing. If you wear loose clothing, long dangly sleeves, if you have like Jedi robes or long jewelry like necklaces or what do you call those things in your wrists? Bracelets, and they dangle and have dangly bits. Neckties are also bad. Those things can get caught and pulled towards the machine. You can never win a tug of war match against a machine. They're built to be stronger and more efficient than us. You will lose, and you will probably lose parts of you. The same instructor, Mr. Howie, is also still alive one day because one day he chose to wear a clip-on tie. And while because he had to wear a tie for a demonstration for some suit-wearing people who wanted to visit our lab, and his necktie got caught in the nip point on a press and started to pull his head into the printing press. Thankfully, he was wearing a clip-on that day, so it just pulled it off his shirt and hurt the machine a little, and he was fine, and everyone was nervous about it. But had that been a properly tied normal tie, that could have snapped a neck. Anyways, the man's lucky. So, machine maintenance safety. There is something called a lockout tag-out device. This is used on lots of heavy machinery, not just printing. So anywhere in many industries, you'll probably see these somewhere. You have big, obvious red power switches, and these power switches can be locked with a padlock in the off position. This way, if you are over maintaining a press and someone else decides to flip it on and try something, they can't. Part of the lockout tagout procedure is these locks only have one key available. That way, only the person doing maintenance has the key to the lock that turns on the power and potentially hurts them. In our print lab on campus, most of the presses are so small that you would have to really not be paying attention to not notice another person on the other side of the press maintaining it. But especially in big places like newspaper facilities where you have a multi-story tall printing press where you have to climb multiple sets of stairs to reach different portions of it with miles and miles of paper web running through it, there's a good chance that you're not going to see someone cleaning some other part on floor 2 or floor 3 of the printing press. That's where lockout tagout really comes good. I can also share a small anecdote here from a friend of mine I used to work with at a hobby shop who had been a Marine Corps aircraft mechanic. It has a story of a careless pilot hopping into his seat of an F-18 and flipping the on switch while he and the other maintenance crew were inside the jet exhaust nozzles maintaining something. The pilot got what was coming to him because they survived. But that's just one of those things. You always check and call for all clear to make sure that no one else is inside a machine before you turn it on. And lockout, tagout, make sure that no one gets hurt. Even just powering up some machines can electrocute someone if they're working on maintaining the electronic components. Let's talk about lifting. You got to lift things with your knees, not with your back. You keep your back straight and your knees bent when you lift heavy objects. I know this sounds like some sort of basic warehouse training, but honestly, printing is quite physical. And you'll find yourself, especially if you work for a big shop and you're starting out, your first job at a print shop will probably be paper feeding, which means moving big, heavy stacks of paper from place to place and stacking them neatly so a printing press can pick them up and use them efficiently. Even if you're not, even in the small shops I worked for, where we were primarily running Xerox digital presses, I still had to move hundreds of pounds of paper all the time, every hour, every day. I moved a ton or two of paper by hand, just picking up a paper box and moving it. And each box weighs like 100 pounds. Paper gets heavy. And if you don't believe me, think about it. You do know this already, whether or not you know it. A sheet of paper is light. Lots of paper is heavy. How do you already know this? You ever helped a friend move? Which boxes do you not want to have to pick up? other than breakables, because you don't want to be liable for breaking things, because I know I break things all the time, it's the book box, isn't it? The books are heavy and you don't want to be the one lifting them. I once helped a friend move, and he put all his books in a giant duffel bag that was oversized, and the thing weighed like 300 or 400 pounds and took two of us to move. All I'm saying is paper is heavy, protect your body. When you're young and strong, you can get away with some things, but once you've spent your body, probably won't have enough money to get it back, and medical science can't bring your body back. If you destroy it, you will forever have problems. Back problems are not something you want to wish on yourself or anyone else. Let's talk about compressed air. Compressed air is a danger. In fact, when I was going through a firefighting, fire extinguisher training for safety on campus as a teacher, we had a firefighter trainer coming in to tell us about how to use the fire extinguishers and how to put out fires. But he also mentioned in this safety brief that when the firefighters are learning about the hazards they face in their job, which, in case you're wondering, involves running into collapsing, burning buildings, the things they're worried about, fire is the third on their list of things they worry about. The three things that kill firefighters more than anything else are: one, falling off of things. If you're on the roof putting out a fire and the fire burns away the support rafters and you fall through, the most firefighter deaths seem to come from falling off of things. Keep that in mind when you're getting paper off of top shelves in a printing warehouse, or you're climbing up onto the top of a tall press system like at the LA Times. Falling from heights is like the #1 industrial and firefighting killer. #2 is rapid air decompression, which is to say explosions. If a air compressor is fully compressed and it loses in structural integrity and it blows, rapid decompression is basically the same as being around a bomb going off. That kills a lot of firefighters too. And a lot of printing applications use compressed air. So my advice here is take good care of your compressors. Make sure you're maintaining them, you're not leaving them on when they don't need to be on, because metal fatigue is real. The more you pressurize and depressurize a piece of metal, the weaker it gets. Submarines don't last forever, and neither do airplanes. Sorry for the Professor Ben airplane aside here. In the late 50s and early 60s, when jet air travel was just becoming a thing for passenger flight, Britain and British Airways, de Havilland was the company, an old British air company dating back to the First World War. They were building one of the first high-altitude, high-speed passenger jets, known as the de Havilland Comet. And it was the height of luxury in air travel, except the first versions had problems. That pressurized cabin, which we're all used to now, you go flying in an airplane and they pump it full of enough air that it feels like you're at sea level and not like you're at 60,000 feet, desperate for air and dying of hypoxia and hypothermia. No, you have yourself a nice pressurized cabin. Well, they hadn't realized on the first one just what a pressurized cabin would do to the metal structure of the airframe itself. And a few of these, too many, one is too many, more than one is way too many, a few of these planes disintegrated at flight because the pressurizing of the cabin caused the metal to wear out and get stressed and break. Also think about if you have a paper clip and you bend it, that's great, you bent it. You bend it again, and that paper clip is now weaker. If you bend it a few more times, the piece snaps off, which is one thing when you're talking paper clips or staples, and something else when you're talking about a tube of air that's going to basically turn into a bomb when its shell fails. Anyways, more things about compressed air. There are reasons to use it. You should never spray compressed air to clean off things. Spraying it on yourself, spraying it on your clothes and your skin is a good way to get hurt. Lots of times it comes through so fast it will actually hurt you. Also, it's possible to spray air through your skin and into your blood itself. And that is a problem too. In fact, there are some forms of injection that they use with a compressed air needle instead of a hypothermic needle that you've probably seen in TV and movies. They just put it up to someone's neck and go, and they're like vaccinated or something. Anyways, that also uses compressed air on the same principle. The big thing is if you spray compressed air and it kicks up dust particles are very dangerous, both for breathing and for fire and explosion. Saying words like fire and explosion are a pretty good ending point for the first half of our video. Stay tuned and I'll send up another one in just a minute.